section 4.3 is on some right triangle trigonometry. Yeah. So at least it's not a left triangle, it's a right triangle. And we love using trigonometry. If you go by like the definition, running out of ink, of trigonometry, anybody know what that is? It's the measurement of something.
I think it's called triangle.
Yeah, probably.
Hey.
So trigonometry, by definition, is just the measurement of triangles. So we like to use trigonometry a lot of times in like navigation, engineering, building, that type of thing. Even the people, the old guys way back in the day, those little Greeks, they actually used to use the stars and make triangles and use trigonometry to sit there and kind of map out some of the stars. Figuring out the motion of the moon to the earth was all done using like trigonometry. So some fun stuff. So back in the day when you guys were wee little high school students, when it came to right triangle trigonometry, we learned sine, cosine, and tangent, and how to look at that right triangle and to be able to figure out sines, cosines, and tangents. So we came up with that little SOHCAHTOA. Remember that? Yeah. So some people like to write SOHCAHTOA like this way, right? I've also seen it written where people will do like the sine is opposite over hypotenuse.
Nope.
Right? Cosine is adjacent over hypotenuse, and the tangent is opposite over adjacent. It's still that SOHCAHTOA. They just kind of wrote it out a little bit different. Kind of gives you that little division kind of part of it, or that ratio. And I think we've all seen these, and we kind of all have that back in our mind somewhere, right? The nightmares of SOHCAHTOA. All right. So, and now that we are the fancy trig pre-calc students, we know these three, but we've been messing around with how many different trig functions this chapter?
Too many.
Not 3, but 6 of them, right? So, and we know that when it comes to some of these trig functions, they have inverses to each other, right? So if we know sine, we know that cosine or cosecant is the inverse to that one, right? So if you think of this, the inverse was that cosecant. So if I wanted to actually use cosecant using some trig to figure out angles of triangles, and we know that they're an inverse, what do you think it's going to be? What over what?
1.
Hypotenuse over opposite, right? Because they're just the inverse of each other, right? And cosine, we know that when it came to looking for those inverses, secant was the inverse of cosine. So what do you think that one's going to be? What over what? Yep, good job. Yep. And what was the inverse of tangent? Cotangent. Yep. Cotangent. And so what do you think cotangent's going to be? What over what?
A over O.
A over O.
Over.
Yep. Adjacent over opposite, right? No, we're good. Right? So we can use these cute little ratios to sit there and evaluate some of those little trig functions, right? So we can start with a fancy little triangle. Whoa. Oh, I forgot. Thank you, thank you. Fancy little right triangle. And then we use capital letters and lowercase letters. What do you think we're going to use the capital letters for? Angles or sides? Angles. Angles. Yep. A for, yep. So, I don't know. We can go angle A, angle B,
Oh,
angle
yeah,
C.
yes.
Right, remember this? Yep. Lower cases are for sides. And remember, there's a relationship between angles and sides, right? If we think of that opposite side, as my angle gets bigger, my opposite side is getting bigger, right? And as this angle gets smaller, that opposite side gets smaller, but my hands didn't change sizes, right?
Yeah.
So there's a relationship between angles and sides, and especially those opposite sides, right? So wherever our angle is, so angle A, if we go to the opposite side of the triangle, that's going to be side A, right?
Oh, I saw this.
Mm-hmm.
This is terrible.
Terrible. It's not going to be terrible now. And if I got my angle B is going to change the side across from it, so that's going to change that side. So that's going to be my little b, right? And that little side across from the 90-degree angle, we know it's going to be side C, but it also has another special name. What's that side of a triangle going to be called? Starts with an H. The hypotenuse. Yep. And just because I'm up on this little board, I usually do my little C's almost like cursive C's, just so that you can tell that it's a little c, not a big C, right? Just for me up here. On your guys's, you probably can, you
How
know.
did you even do that?
You just, yeah, but I have sloppy handwriting, so yeah.
Oh, that's cool. I
Right.
just really
Really tiny, yep.
I'm gonna.
Yeah. Don't you remember, like, when you used to, like, write in cursive, you know, like, and you'd be like, cat.
I just do a regular C.
I know. You know, back in elementary school, that's how they taught me. Yep. All right. So then now I can sit there and take my little triangle. Whoops, and I'm going to throw some measurements in there. I know. So let's just say like angle or side A was 5 centimeters, right? And B was 12 centimeters. And then I need to somewhat name one of my angles like that I'm talking about. So in trig, a lot of times we like to use that little theta. So like I'm going to go, whoa, no, I'm not going to erase. I'm going to go off of angle A. And so on angle A in the inside, I'm going to put that little theta. And it's just kind of like a circle with a little swoop in the middle. Right? It's like Donald Trump's hair. Circle though. I don't know. It was worth a shot. All right. So I know that I have a right triangle. So in order to figure out kind of like all of my little trig identities, all of my little functions up here, I need to know all 3 of the sides, right? I need to know the opposite, the hypotenuse, and I need to know the adjacent from this angle. So I know this side and I know this side, but I don't know what C equals. So how am I going to figure out what C equals? Pythagorean Theorem, yep. Oop. Right. So Pythagorean Theorem was our little a squared plus b squared equals c squared. So let's see if we can put 2 and 2 together, right? Well, we'll write it out. So what do we got? 5 squared plus 12 squared equals c squared. What do we got? 25 plus 144 equals c squared. What's 25 plus 144?
169.
Yep, 169 equals c squared. Take the square root of both sides. C equals positive and negative 13, right? Because we're taking the square root. Whoops, sorry guys, I didn't make that big for you. But we want where C is just the positive, right? Because we're talking about a distance. We can't have a negative distance. So we know that C is 13. So now let's just go through and see if we can figure out our 6 trig functions, right? So if I want to do the cosine, and I'm going to do cosine from theta, because I got to know where I'm taking this baby from. So when it comes to figuring out opposite adjacent, we have to know what angle we're looking at, because it's going to be different for different angles. So I'm talking about theta, okay? So if I want to find the opposite side, I got to go to the opposite side of the triangle. So this guy is our opposite side, right? This guy's going to be our, C is going to be the hypotenuse because it's across from the right angle. And then B is going to be the adjacent, yep. And what does adjacent stand for? What does that mean?
Next to.
Next to, right? The way I think adjacent is really close to Jason. So everybody wants to sit next to a Jason, right? So it's next to, right? All right. So cosine is opposite, or no, adjacent over hypotenuse. So what's cosine going to be? What's adjacent?
Cosine?
Yep.
Adjacent, which is 5.
12 over 13.
Yeah. Right? You're all right.
It's so good.
Right. Sine of theta. Sine is opposite over hypotenuse. So that's going to give us 5 over 13. Yeah. Tangent is opposite over adjacent, so that's going to give us 5 over 12, right? And then the three newbies, right? Cosecant of theta is going to be hypotenuse over opposite, so hypotenuse is
13.
over 5, right? The other thing you can do is we know that cosecant is the inverse of sine. And are they flipped?
Yeah.
Right? Yep. Secant of theta is the inverse of sine, or cosine, sorry, cosine. So that would give us 13 over 12, right? Cotangent is the inverse of tangent, which would be 12 over 5, right? Or we can go from our little explanation up here. Yep.
Just, we're gonna need to know like all of those, like we're gonna have to memorize like all the 6 and then that for our test.
Right. Yep. Yep. And really, like, I mean,
It's not that hard, but like,
yeah.
it's
And
just a lot.
yep. And then the biggest thing is just kind of like remembering the inverses, like which one is the inverse of which one. And I think the tangent and the cotangent, that's a little self-explanatory, right? And then the way that I remember them, if you're looking for sine and you want the inverse, it starts with the C. If you're looking for cosine and you want the inverse, it's the one that starts with the S, right?
Those
Right.
are the ones opposite to each other. Too.
Yep. Yep. Yep.
Reciprocal identities.
Yep. Those are those reciprocal identities. Yep. Exactly. All right. Nice. So then, yesterday, when we went through and we did like the sine, the cosine, and the tangents all on our homework, and we were kind of going off the unit circle, we can do that now with even right triangles. Really? Yep. So if we had a little right triangle, oh yeah. Oh my goodness. How can this thing not know what I want to draw, right? And I don't know, I'm going to go with like a 60-degree and a 30-degree triangle just to make it nice and fun. And I'm going to say this guy is 2, so that would make this 4, and this would make this 2 times the square root of 3, right? Being a legit 30, 60, 90 triangle. And if I wanted to find the cosine of 30 degrees, I know that cosine is adjacent over hypotenuse, right? So from my 30-degree angle, I need to know which side is my adjacent. So what's adjacent to 30 degrees? So next to 30 degrees.
2 square root of 3.
Yep, 2 square root of 3. Over the hypotenuse, and we know the hypotenuse is always the opposite side of that 90-degree angle, so over 4. And then I could just simplify that down to what, the square root of 3 over 2? Right? Because my whole numbers reduce. What about if I had the tangent of 30 degrees? So tangent is opposite over adjacent. What's opposite?
2.
Yep, what's adjacent? 2 square root of 3, right? Can't leave that little radical in the denominator, right? So you can either simplify it first, or you can just multiply top and bottom by square root of 3 and then simplify the whole thing. So this is going to be 2 times the square root of 3 over 6, which is going to reduce down to the square root of 3 over 3. If I asked you what the tangent of pi over 3 is, and I only give you this picture, so we need to figure out which angle corresponds to like pi over 3. So we can either go from radians to degrees, or we can look at our unit circle, one way or the other, right? So if I did pi over 3, that would be like 180 over pi, which is going to give me 60 degrees, right? So then I could rewrite this as the tangent of 60 degrees, and then go from there. So then now my opposite is 2 times the square root of 3. And my adjacent is 2. And the square root of 2's cancel. Right? So sometimes I just give it to you as a picture. Not too bad?
No.
Alright.
4?
Yeah!
Oh.
We gotta keep going on with these little triangles. Yeah. So sometimes they want us to find the angle or the side. Oops, can't do shapes. So they might want us to find the side, or they might want us to find the angle. So we got a cute little triangle. Oh boy. There we go. Cute little right triangle. And I don't know, let's say this guy's 37 degrees. Let's say this side's 250 centimeters. That's a really bad. And they want us to figure out this side. I'm just going to call it X for the fun of it. Right? So we need to figure out if we want to use sine, cosine, or tangent. Granted, you could use cosecant, secant, and cotangent if you wanted. It's your choice. But for right now, I'm just going to stick with the 3. Right? So I always have to go from the angle that they give us. So what angle did they give us? 37, right? So we need to figure out the two sides that we have information on, what these two sides are in relationship to that 37 degrees. So my X would be what side? Opposite, adjacent, or hypotenuse? Opposite, right? 250 would be adjacent. So if I'm looking at opposite and adjacent, am I looking at sine, cosine, or tangent? Tangent, right? And the tangent of theta is opposite over adjacent, right? So the tangent of our angle, which is 37, is going to equal opposite x over our adjacent 250. Makes us warm and fuzzy inside if we make these two fractions. So we're comparing the same things, fraction to fraction. Right. So these guys are proportionate. So in order to solve it for x, we can cross multiply. So x times 1 is going to give us x. And then this is going to be 250 times the tangent of 37. That tangent of 37, that whole entire piece is one number. Right? Don't multiply the 37 and the 250 together. Right? This is one number. So we can just plug that into our calculator. We need to make sure that our calculators are in degree mode. Because are we talking about degrees or radians? We're talking about degrees. Yep. So we're going to plug that into our calculator, and you should get approximately 188 centimeters. Right. Sound good? Mm-hmm.
Got it.
All right. I got one more quick one for you. So let's say we got our fancy little triangle again. Not necessarily drawn to scale, just for demonstration purposes. I'm going to say this is my theta. And we got 155 feet and 1,320 feet. So now instead of finding my side, they want us to find our angle, right? So again, we got to go from our angle. They gave us opposite and they gave us adjacent. So we're going to do the tangent. So tangent of theta is opposite over adjacent, right? So for us, the tangent of theta, because we don't know what it is, equals opposite 555 over adjacent 1,320. Okay. So for us, we want to get that tangent all by itself, or that theta all by itself, so we have to get rid of the tangent. So in order to get rid of it, you multiply by the inverse. So you're actually doing the tan inverse of tan theta equals the tan inverse of 555 over 1,320. If you take a number times its inverse, it cancels out. So that cancels out the tangent. So you're left with theta equals the tangent inverse of 555 over 1,320. The inverse, if you're on your calculators, it's that second tan. And then we should get to our theta equals like 23 degrees. Coming back to you a little bit. I know we've worked on these before. Yep. So anytime you're looking for that angle, you're always going to have to take that inverse. Yep. On Desmos, there's a little part. I guess I can pull it up real quick for you. On Desmos, there's this little main, this ABC, and then there's function. Under that function, it gives you the sine, cosine, tangent, and it gives you all of the inverses. Right? You just got to make sure you switch over to that function part off of the instead of main.